Hi again, this is Colt, and this is my new H-bridge that is going to power this motor. This motor's got quite a bit of holding torque, or not holding torque, but just detent torque here. I can hardly spin it like that, and then so it's rated at 5 amps, and that's what this H-bridge does. It allows 5 amps to reach the motor, but no more than 5 amps, so this doesn't overheat. It's only going to get its rated amount of amperage, but its resistance is pretty small, so running it at 12 volts it wants to draw about 20 amps, and that's where the problem occurs. This computer power supply is capable of supplying 18 amps, which this motor is actually drawing 20 amps, so if I just hooked it up straight across, it would fry something, most likely the power supply. So now this H-bridge is special because it limits the amount of current that is going to the motor, and how it does that is it regulates the voltage to the motor. Because the motor has is an inductor, basically when you turn it on like a light switch, it doesn't turn on like a light, it doesn't turn on instantly. There's a time delay for the current flow, so there will actually be, like, when you switch it on, the current will start rising slowly up to the 5 amps, which is what I have it set off. So the rate at which it climbs up to that current is a function of your voltage. If you have a really high voltage, it's almost instantaneous. If you have a really low voltage, it takes a long time to get there. So this is 12 volts. It's pretty good. I think I got it to maybe, I don't know, 100 RPM or something like that. That's pretty good for a stepper motor, considering it has to turn on and off about 200 times each revolution. It's pretty good switching quality. So what we got here is this H-bridge is actually has quite a bit going on. So here's like my first side. It's just a single H-bridge. It controls one of the windings on the motor, and then here's my more compact other side. So this is the right side and the left side of the H-bridge. This is our current limiting breadboard. So each one of these is limiting the current to each one of the windings for each direction. Unfortunately, I can't really think of a better way to use only one, because they're kind of expensive, about $1 or $2 for each one of these. I did initially think we could use the just a single one, but that would change the voltage on the control aspect of it, so some of the control system wouldn't work if we were limiting the current in front of the entire H-bridge. So instead we have to limit the current inside the H-bridge. So now how the heck do you control everything here? Well, we got this guy over here. This is actually the brains of the entire system. It's able to run at 16 megahertz. It's MSP 430 launchpad. Basically, throughout this entire H-bridge, there's 3 voltage rails, because this guy, he can't run at 12 volts. He runs at 3.5 or something like that, 3.5 volts. So essentially this whole circuit, everything here is just getting the 12 volts down to a manageable 3.5 volts. And also there's a 7.5 voltage rail in here somewhere, and it's basically in between. These guys are at 12 volts and these guys are at 0 volts, essentially, and we need a switching mechanism in between 7 volts. So basically the 7 volt rail brings these guys up to 7 volts and brings these down to 7 volts, and it turns them on when you do that. Yeah, so let's see this baby work. So I have some code loaded into here, and it's running. It's about as fast as I've been able to run the motor. The step size is pretty small, about as small as I can get. I think we can probably improve that. But it seems to run pretty well, and I can't even stop it with my hand, so that's pretty good torque. So let's shoot. I don't have my tape on here. Hold on a second. So you guys can see what the heck's going on. Okay, so we got like a little flag. So yeah, let's turn this on. Everything's gonna load up here. So it's starting to run. So each one of these LEDs is basically the winding, and you can even like see that it's turning off and on, but each one of those is turning off and on at I don't know, about 200 times every half second, I guess. Or no. I'm not sure. But yeah, anyway. So yeah, this is basically controlling everything else. I still need to get heat sinks on these, so I'm not going to run it for very long. Each one of these is, it's not warm, it's warm, but it's not hot. These aren't very warm either yet. But, I mean, if you leave it run for, I don't know, 10 minutes, it gets pretty, or not even 10 minutes, like a minute or two, it gets pretty warm. So, that's all I have for this. Alright, thanks.